Hi, everyone. Just wanted to go over those problems that people were bringing up in discussion, and then hopefully get you started on how to solve some of them. So the first one I got requested was number 15 from the homework. So this is number 15. So if we look at this one, we're saying a licensed nurse practitioner, I appreciate that they included she was licensed, is instructed to give a patient 1,500 milligrams of an antibiotic over a period of 36 hours. If the antibiotic is given every 4 hours starting immediately, how much antibiotic should be given in each dose? To answer this question, solve the equation 9x equals 1,500. So if you're wondering where this actually came from, why are we using 9? It's because over the 36 hours, we were giving it every 4. So essentially, if you did the 36 divided by 4, we have 9 different doses. All right, so if we then look at this, we would just solve this. We have 1,500. We divide by the 9. Divide by the 9. So ultimately, I'm not going to leave it as this. I am going to need to simplify this. So 9 is the same thing as 3 times 3. And 1,500 is the same as 3 times 500. So if we were to plug this in, we know that these will cancel. So that'll leave us with just 500 over 3 milligrams. That's all you're going to need to do on this particular problem. So let me just erase that, and then we will look over at the next one, which is going to be number 16. Just want to make sure that was cleared out. Okay. Let's look at the next problem. All right, so there are 9 water bottles in Devin's refrigerator. He adds 3 full boxes of water bottles to the refrigerator. He then adds 2 more boxes that each has one fewer bottle than a full box. All right. When he is done, there are 67 bottles in the refrigerator. So we're going to write an equation to find and solve to find the number of full bottles in the box, in a full box. All right. So we do need to be careful because our variable here is we're looking specifically for a full box, right? So if we call X, we're going to call that a full box. So we do not need to make sure we're defining our variable appropriately. So let's figure out what we have at the end. At the end, we know we have 67 bottles at the refrigerator. So no matter what I'm doing, at the end, I end up with 67 bottles, right? And we're told that we're putting 3 full boxes in the refrigerator. So 3 times however many bottles are in a full box. We're adding 2 more that has 1 fewer than a full box. So we're doing 2 times, and we're going to do x minus 1. We're doing x minus 1 because this is bottles. Should be more clear. This is bottles in a full box. All right, so we're doing bottles in a full box. And the other thing we need to know is we started with 9, right? So 9 plus this. So this is where this equation comes from. We're doing x minus 1 because there's 1 fewer bottle in each of these boxes, right? This is a full box. That's why I'm leaving it as x. And then I just had 9 to begin with. So we'll simplify this. 9 plus 3x plus 2x minus 1 equals 67. So that ultimately means we'll have 5x plus 8. Oops, I made a mistake. I'm sorry. I have to distribute the 2 to the x and to the 1. So it's not minus 8, it is minus 7. I lied. Plus 7. Sorry, plus 7. So let's subtract the 7. Minus 7. So I get 5x equals 60. X equals 12. So there's 12 bottles in a full box. Is essentially what that's doing. And again, all we did here is we were saying there was 3 full boxes and there's 2 boxes with one less bottle for whatever reason. All right, so I'm just going to erase that. Oh, that's so lovely. I didn't know that existed. All right, so the next question I had was number 18. Let me just make sure. Yep, 18. So let's go over number 18. So a scientist makes an acid solution by adding drops of acid to 1.2 liters of water. The final volume of the acid solution is 1.202 liters. Assuming the volume of each drop is 0.05 milliliters, how many drops were added to the water? Well, what percent of the solution is acid? All right, so we do need to be careful on this particular problem because you'll notice we're dealing with liters and with milliliters. Now, I don't care which one you convert to, but you are going to need to convert. And quite frankly, I'm just going to convert to, I don't know, let's convert to milliliters just for simplicity. So 1.2, that's the same thing as 1, 2, 3. So 1200 milliliters. Then 1.202 would be 1002 milliliters. And to look up the conversions, you can just look up the way to convert from milliliters to liters, or liters to milliliters, I should say, because we're going to the right, essentially. We're getting smaller, so we need to move the decimal place to the right. Okay, so we're being told that the final volume is this. So this is our final volume. We're starting with 1200. Now, we know we're adding an amount of drops. I don't know what yet. So my X is going to be my number of drops. And for each one of those drops, we're getting 0.05 milliliters. Okay? So that's how we're going to set up this equation. And all I did in this case was convert everything to milliliters. And that way, I can tell you exactly how many drops of acid we're going to have to put in. Okay, so we're going to subtract the 1200 minus the 1200. 0.05x equals 2. Okay, so again, we only did the 0.05x because that's the number of milliliters times the number of drops, right? Because if I, was putting in if I was putting in 1 milliliter with each drop and I put in 6 drops, I'd be putting in 6 milliliters. That's why I'm doing this particular one. All right, so now we just have to divide by the 0.05. Divide by the 0.05. So 2 divided by 0.05 is 40. So I am ultimately putting in 40 different drops of acid. Now, let's look at what we are dealing with in terms of the percent of the acid solution is acid. So we have to ask ourselves, what percentage of the total solution is acid? And to do that, we know that we are putting in 40 drops. So if we're putting in 40 drops and we multiply, essentially we're putting in 2 milliliters, right? At the end, we are putting in 2 milliliters of acid. And we know that because if we plugged in this, the number of drops times the amount per drop, it's going to give us 2. That's exactly what this told us right here. That's what this was saying. 0.05 times the number of drops is equal to 2 milliliters. So we know that we have 2 milliliters of acid, okay? And we are dealing with 1,202 milliliters of solution. So 1,202. So ultimately, that is 0.0016, and so on. So if we were to convert that into a percentage, that is 0.166%. And it is 0.166% acid. And if you wanted to check that, you could plug it in. So this is asking me for the number of drops. So we're looking for 40 drops. We can check our answer. Excellent. And we're rounding to the nearest hundredth, so I didn't round. So it'd be 0.17. Excellent. Okay, so let's move on. The last one that we needed to focus on was this lovely problem about bricks. So let me start going through this. A mason will lay a row of bricks to build a wall. The mason will spread 3/8 inch mortar on top of all but the last row of bricks. The wall will be 1 1/8 inches less than 4 feet high. And so I have to answer the questions below. So A is asking me, Mason wants to lay the brick so that the shortest edge of the brick is vertical. Now, the shortest edge of the brick right here is this lovely 2 1/4 because it's less than 3 and it's less than 8. So that's my vertical side. Now, how many rows of bricks do I need? So essentially what we have to ask ourselves is each row, we're getting a 2 1/4 inch height from just the brick, right? So from like the first row, I have 2 1/4 inches from the brick itself. But then I'm on top of that putting 3/8 of mortar. And I'm doing this for however many times I have a row, right? So if I had 7 rows, I would do this 7 times. The only problem is it tells us right at the beginning, all but the last row. This equation, this expression right now is giving us this for every row, and we're saying that this 3/8 is happening every single time. So I do still have to subtract out a 3/8, okay? And ultimately, that is going to be equal to 4 feet, which I want to convert that to inches because everything else is in inches. So that is 48 inches. And then minus 1 1/8 inches as well. And you could combine that before you do this setting equal to each other. So if you solve this all out, you would be able to figure out exactly how tall it would be. So what I'm going to do is I'll distribute the x. So 2 1/4 x plus 3/8 x minus 3/8 equals 48 minus 1 1/8. So all I did was I just distributed that x to those particular things. Now I'm gonna make all these mixed numbers and I'm gonna turn them all into improper fractions. So if I had 2 1/4, that would be the same thing as 9/4. Sorry, I just made a quick little mistake in my head. Plus 3/8 x minus 3/8. And if I had the 48, and then 1 1/8 would be 9/8. Now it's pretty obvious at this point that the least common denominator is going to end up being 8. So if I multiply everything by 8, I'm going to clear out all the denominators. But you do need to be careful because when I multiply that one by 8, I still have to multiply this by 2. All right, so let me just write that over in the corner so that we can all see what it is. So we have 2 times 9, which is 18x, plus 3x minus 3 equals 48 times 8, which if you check on your calculator, is going to be 48 times 8 is going to be 384. Alternatively, what you could think to yourself is, what would be 8 times 50? That would be 400. And then you could subtract out the remaining 6 right? Because it's 2 less. So that's another way you could think of it. So 384 and then minus 9. So now we can actually simplify this. So this would be 21x. I'm going to add the 3 to this side. So when I subtract this from 9 from this, I'd get 375, and then I'm adding the 3, so it'd be 378. When I divide by 21, I'm going to get 18. So it will ultimately end up being 18 inches tall. Okay. So let me just read through that to make sure I'm answering everything. Let B be the number of bricks. It would be the total height of the bricks would be 2 1/4 times the number of bricks. The total height of the mortar is equal to 3/8 times B minus 1. That's another way you could think of it. That's essentially where this minus 3/8 comes from. The sum is equal to 48 minus 1 1/8. So that'd be 47 and 7/8. No, 46 and 7/8. I'm sorry. 7/8 inches, by where it will result in 18 rows of bricks. Okay, nice work. Okay. Suppose the mason decides to lay the bricks so that the 3 inches vertical and the same number of rows that we used. How tall will this be? So basically what we're saying is instead of doing 2 1/4, I'm just switching this out with 3. Okay? So instead of this, I'm going to switch it out with 3. Okay, so that should be the only thing that I'm really missing and changing here. So I'm changing this to a 3. So that would be 3x. So now instead of, it would be 24, right? Because I'm still multiplying by 8. So I'd get 24x plus 3x. So that'd be 27. Everything else should still be the same. So I still have 378, but now I'm dividing by 27, which is now going to be 14. Okay. Oh, that would be, oh, same, I'm sorry, I just did that entirely wrong. I misread the problem. This is why you should always read the problem entirely. So it's not going to be 14, I lied. So instead, we are going to deal with a situation where we have, instead of 2 1/4, we're replacing it with 3. So it's 3 times the number of bricks plus 3/8 and b minus 1 from their equation. And that's equal to something. Except b we now know is 18. So 3 times 18 plus 3 over 8 times 17. And we can simplify that. So 3 times 8, 3 times 18 is 54, right? So 54 plus this is going to be 51 over 8. So if I wanted to get the 54 over the 8, this would be 2. Whoop, 432 over 8. 432 plus 51. So ultimately, my answer over here, it's very hard to see, but it's going to be 483 over 8. So 483 over 8 is ultimately going to be our answer. Oops. I was using a shortcut. And there we go. There you have it. So I apologize that I made a mistake and misread the question at the second part of B there. But hopefully these help answer your questions. And if not, please let me know and I will be happy to help. Have a great day, everyone.